Okay, so now we're back here for part 2. And for this one, warm-up probability day 2, we're going to look at another classic probability situation, marbles. Okay, rolling marbles. So in this problem here, Mr. Covell has a bag of 20 marbles, 4 red, 7 blue, 3 green, and then 6 white. If we add 4 plus 7 plus 3 plus 6, that is indeed 20. So that takes care of all of our marbles. You reach into the bag and you pull out 1 marble. What is the probability that it is red? Well, probability, going back to part 1 here, the idea of probability, it's the number of ways for an event to happen to be successful divided by the total number of ways that or outcomes that we can have. Okay, so here, the probability, I'm going to write P, and I can just use R for red. So the probability of red, that's how I'm reading this. Well, the number of ways to be successful, how many reds are there? 4. So that is my numerator divided by, what is the total number of outcomes? Well, they told us we have 20 marbles. So it's 4 over 20. You could simplify that, divide by 4, we get 1/5, which is also 0.2. Okay, as a percentage, that would be like 20%. What's the probability? Now, let's assume here that the marble goes back, okay? So each time we do this problem, we're starting with our 20. What's the probability that the marble is blue? Well, how many blues do we have? So there are 7 ways to be successful out of 20, which is 0.35. This 7 out of 20 is already simplified, so I can leave it as that. What's the probability of green? So probability of green, we have 3 green. So 3 ways that we can pick green divided by 20 total ways to choose a marble, which is equal to 0.15. Now, one thing, I'm going to put a second problem or another problem here. What about the probability that it is not green? Let me put the word not in front. And I'm going to show you there's 2 ways that I can think about this. The probability of not green, well, what would be successful for not green? Anything that's not green would be a success. Well, that means red, blue, and white would count as successes. So we're thinking red, blue, and white. Well, we have 4 red, we have 7 blue, and we have 6 white. So it could be red or blue or white. I'm going to add those. So what I'm doing here is getting the total, which is 17. So 17 not green marbles. So the probability of not green would be 17. That would be a success. Success in this case is not green out of 20, which is 0.85. Now I want you to notice something though. There was probably an easier way to do this. We know that the probability of green was 3 over 20. And the other idea is that if I take the probability of a green marble and I add that to the probability of a not green, that would take care of all my marbles because they can be green or they can not be green. Those are the only possibilities. If I add those up, that's 100%, which is equal to 1. That's the total probability of any situation. If I already know that the probability of green is 3 out of 20, so in this case, 3 out of 20 plus the probability of not green is equal to 1, then my question is, well, what's left over here? What would this have to be to add to 3/20 to get me 1? The idea is that I could just subtract 3 over 20 to the other side. I could move that like an equation. If I take 1 minus the probability of green, everything left over is not green. And so with a little fraction arithmetic, well, this is 20 over 20 minus 3 over 20. And what that gives me is 17 over 20. So in other words, you can think, all right, if green is 3, then everything else is not 3. So 20 minus 3 is 17. My answer is 17 out of 20. Okay, so I can either add up all of the not greens, which I did here to get to 17, but I could also just take away the green, the 3, and what's left, the 17 out of 20, is not green. Okay, what is the probability that the marble is white? Well, let's see, we had 6 that are white, so 6 successes, 6 ways to succeed out of 20 total outcomes, which reduces, we can divide by 2, 3 over 10, or 0.3. What's the probability of red or blue? Whoops, probability of red or blue, R or B? Well, that means when we see or, it could be either of them. We have to count them all. So we have 4 red, we have 7 blue. So if we add those up, we get 11 out of 20, which is 0.55. Blue or green? Well, 7 blue, 3 green. So the probability of blue or green, how many ways can we succeed? 7 plus 3, which is 10. Okay, and you don't have to write it down, but I'll write that little work right there. 10 out of 20 as a fraction, that is 1/2, which is 0.5 for that. And then for the red or blue, that was also 4 plus 7. That's how I got the 11. What's the probability of not blue? Now this is where we can do this 2 ways. This is kind of like the one that I did here. Not blue means it could be red or green or white. And so I could add those up, but I could also just take the probability of not blue, take 1 minus the probability of blue, which we already got here. The probability that we choose a blue marble is 7 out of 20. Everything else is not blue. So if I take 1 minus 7 out of 20, and as a common denominator, 20 out of 20 minus 7 out of 20, I get 13 out of 20, which is 0.65 as a decimal. Now again, if that seems kind of confusing to you, well, just count all the marbles that are not blue. 4 red, 3 green, that's 7, 4 plus 3. 7 plus 6 white is 13. So 13 not green, or not blue, sorry, out of 20, which is 0.65. What's the probability of red, white, or blue? All right, now in this one, red, white, or blue. So we have 4 red, we have 6 white, we have 7 blue. So the number of ways, red, white, or blue, the number of ways we can do this, there's 17 successes out of 20, which is 0.85. And then the last one, what's the probability of blue and green? That means we choose one marble and it's both blue and green. But see, that's not possible because it's either blue or green, but it cannot be both. We don't have a blue-green marble. So this is kind of a tricky question. That probability is 0. And that is the end of part 2.